In my last video, we have learned very important atom model, Rutherford's atom model, then the concept of mass number, the composition of atom, etc. Okay, Rutherford's atom model has certain drawbacks. The main drawback of Rutherford's atom model is it could not explain the stability of atom. Okay, then a new model of atom was developed by Niels Bohr, which is known as Bohr's model of atom. Okay, students, today I am going to discuss the developments leading to Bohr's atom model. Developments leading to Bohr's atom model. Please listen. The studies of interaction of radiation with matter provide more informations about the structure of atom and the molecules. The two developments which lead to Bohr's atom model are: number one, dual nature of electromagnetic radiation. Number two, experimental results obtained from atomic spectra. Okay. Then, what is meant by dual nature of electromagnetic radiation? Electromagnetic radiations like light behaves as particles as well as waves. That means the wave-like and particle-like properties. The wave-like and particle-like properties. Wave-like and particle-like properties of radiations are called radiations is called dual nature of electromagnetic radiation. Okay, then what is meant by wave nature of electromagnetic radiation? Wave nature of electromagnetic radiation. Yes, let us discuss about the wave nature of electromagnetic radiation. Wave nature of electromagnetic radiation. Wave nature of electromagnetic radiation. Okay. In 1856, famous scientist James Clerk Maxwell proposed that light, we know light is an electromagnetic radiation. Light propagates through space in the form of waves. These waves associated with electric field and magnetic field and are called electromagnetic waves or electromagnetic radiation. What are the main characteristics of electromagnetic radiation? Number one, electromagnetic radiation associated with the electric field and magnetic field. Number two, electromagnetic radiations do not require medium for its propagation. Number three, all electromagnetic radiations travel with the same velocity. The velocity of all electromagnetic radiation is 3 into 10 raised to 8. 3 into 10 raised to 8 meter per second. These are the main characteristics of electromagnetic radiation. Yes. Then this electromagnetic radiation possesses wavelength, frequency, velocity, wave number and amplitude. Okay. What is meant by wavelength? What is meant by wavelength? Lambda. Okay. Yes. This is the direction of propagation of wave. We know the upward portion of a wave is called crest, and the downward portion of a wave is called trough. Yes. What is meant by wavelength of a wave? Wavelength of a wave means it is the distance between two consecutive. Yes, wavelength of a wave is the distance between two neighboring crests or troughs of a wave, and wavelength of a wave is expressed in Armstrong unit. Armstrong, usually the unit of wavelength is Armstrong. 1 Armstrong is equal to 10 raised to minus 10 meter. Similarly, 1 nanometer is equal to 10 raised to minus 9 meter, and 1 picometer is equal to 10 raised to minus 12 meter. Yes. Next, number 2, frequency of a wave. What is meant by frequency? Its symbol is nu, or yes, we can read it as nu. What is meant by frequency of a wave? Frequency of a wave means what? It is the number of waves passes through a particular point in 1 second, and its unit is hertz or cycle per second. Yes, 1 hertz equal to 1 CPS, or we can write 1 hertz is equal to 1 second inverse. And frequency of a wave is always inversely proportional to wavelength. When wavelength of radiation increases, its frequency decreases. Okay. Yes. Next, number 3, wave number. Wave number, its symbol is nu bar. Wave number. Wave number is the number of wavelengths per centimeter. Wave number is the number of wavelengths per centimeter, and wave number is the reciprocal of the wavelength. Nu bar is the symbol. It is the reciprocal of the wavelength. Next, amplitude of a wave. Number 4, amplitude. Its symbol is A. Amplitude of a wave is the height of a crest or depth of a trough of a wave. Height of a crest or depth of a trough of a wave. Amplitude determines the intensity of wave. When intensity of radiation, yes, increases, amplitude increases, or we can say when amplitude of radiation increases, intensity of radiation increases. When amplitude of radiation increases, intensity of radiation increases. Okay. And next, velocity. Velocity, its symbol is C. The velocity of electromagnetic radiation can be represented using by the symbol C. We know all velocity means what? It is the distance traveled by a wave in 1 second, and the velocity of all electromagnetic radiation is 3 into 10 raised to 8 meter per second. Yes. Then cosmic rays, gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, radio waves are electromagnetic radiations. Then we can arrange these electromagnetic radiations in the increasing order of the wavelength. The arrangement of electromagnetic radiations in the increasing order of the wavelength is called the electromagnetic spectrum. Yes, this is electromagnetic spectrum. Cosmic rays, gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves and radio waves. Okay, that means the arrangement of electromagnetic radiations in the increasing order of the wavelength or decreasing order of frequency is called the electromagnetic spectrum. Yes. Yes, C represents velocity of electromagnetic radiation, and nu represents the frequency of electromagnetic radiation, and lambda represents the wavelength of electromagnetic radiation. Then the relationship between the velocity c, frequency nu and wavelength lambda is C is equal to nu lambda. Yes, very very important relation. Okay, velocity of electromagnetic radiation, C is equal to nu lambda. Okay students, goodbye.